All right, so section 2.4 is about graph transformations. So taking a graph that you're really familiar with, so maybe a parabola, and looking at how that equation changes if we shift it up or down, left or right. Okay, so let's start out with a practical example. To save money, an office building is kept warm only during business hours. The figure shows the temperature H in degrees Fahrenheit as a function of time T in hours after midnight. So midnight is T equals 0, and the building's temperature is 50, and it stays at 50 degrees until 4 a.m., and then by 8 a.m., they've heated it up to 70 degrees, which is when people start arriving there. And then right before the end of the workday at 4 p.m., so over here, the building starts to cool down, and by 8 p.m., it's back down to 50 degrees again. Suppose that the building superintendent decides to keep the building 5 degrees warmer all the way across the board. So that 50 would become 55, the 70 degrees would become 75, and so on. Sketch a graph of the new function. All right, so if anything that was 50 degrees is now supposed to be 55 degrees because we're adding 5 to the temperature. I'm going to have this. And so I'm moving these places where the lines meet up. That's what I'm marking with these dots. And I'm moving each one up 5 units, more or less. Okay, so that's what our new graph would look like. So it has that same shape. The shape itself hasn't changed. All it's done is it's just been bumped up 5 units. All right, so we're going to try this out with x cubed, so a cubic. And what I'd like you to do is fill out the table of values and then sketch the graph for both of these. You can go ahead and pause the computer, do that. One easy way to get those values in the table is to put the function into your graphic calculator if you have one. Make sure your table is set at -2 and it's going up by ones. And then we can hit the table button and we can get our values and write those down. So give that a try, pause the video, and we'll come back after you've filled in the tables and the graphs, and we'll see if we can come to some conclusions here. All right, so hopefully you gave that a try, and let's see if we got some of the same numbers and the same values here. So here's what my graphs look like in my table of values. Okay, and then we have this box at the bottom to fill in. So we're looking at this. So it says, suppose f of x is a function and k is a constant. So we want to make a conclusion here about what adding plus k to that function f of x does. So if we are looking at this picture here, this one has a +1 to it. So that would be the idea of plus k. And it looks like our graph got moved up. Whereas on this one, when we subtracted 2, it looks like our graph kind of went downwards. So our conclusions here are that if we add a constant to the end, it's going to shift upward, and it's going to shift upward by k units. So if we know what x cubed looks like, then we know that x cubed plus 7 is the same graph, just bumped up 7 units. If we subtract k, it's going to go downward by k units. Okay, so there are our conclusions from adding and subtracting a number to our function.